we're going to solve exponential equations. So the difference between this and what we were doing before is there is a variable in the exponent, and one side of the equation is, so we'll call in this case the left side and the right side, are set equal to a value. So because there is one exponent, it is very possible that we can isolate and solve for this one exponent. The trick becomes isolating for it. Okay. What we have here is we have two sides of an equation. One with a base 2 and one with, 8 is technically to the power of 1. 1 to the base 8. Also, one's a fraction, one is not. We can make this one a fraction. We can say that that is over 1. That makes it maybe a little easier to look at, or at least it looks like we're dealing with fractions. But in order to do this, we need to make sure our bases are the same. Now, it'll probably be easier to deal with the base 8 that has no variable attached to it. So the first thing I want to do is think of prime numbers. You remember prime factors? Did you ever do that stuff? Long time ago, they may have done it in elementary school for you. And you're looking for the most basic numbers that multiply together to make something. So for instance, the prime factors of 2 are 2 and 1. It's a prime number 2, okay? The number 8, though, I can break up. What can I break this into? Well, I can break this into 2 and 4. And 2, we've already established, can't be broken down farther. But 4 can. 4 can be broken into 2 and 2 again. So the prime factors of 8 are 2 times 2 times 2. But we're dealing with exponents, so we can actually rewrite this as 2 to the power of 3. So the very first thing that I'm going to do here is I'm going to replace my number 8 to 2 to the power of 3. And the reason we're going to do that is because this is of a base 2 and this is of a base 2. We've made the bases the same. That's going to be really helpful for what we need to do. So my next line here is I'm going to say 2 to the power of 2x plus 2. I'll still keep it as a fraction, just because our other side is a fraction. And I'm going to rewrite this as 1 over 2 to the power of 3. Okay? Gabe, can you tell them not to go on that, please? Now, this here, we've talked about it before. When we have an exponent and it just so happens the power of 1, I can put the power of 1 to any exponent I want because it will not change it. So I'll put it in a different color. I'm just going to put it to 3. And the reason I'm going to do that is because what I can now do is I can rewrite this as 1 over 2 to the power of 3 here. Okay? Now that we've done that, we need to make these bases the same. Well, I need to make this fraction the same. Right now, one is 2 over 1. The other is 1 over 2. So in order to make this look like it's 2 over 1, flip it. I'm going to turn this into a negative fraction, or a negative power. So we still have 2 over 1 to the power of 2x plus 1 is equal to 2 over 1. And the only change we made here is the power became a negative. Okay? What's nice about this is once the bases are the same, and I can rewrite these. I'm going to rewrite them so they look a little easier because you don't technically have to make the fractions. Oh, I changed this by accident. Little transposition error here. Okay, is equal to 2 to the power of negative 3. Once your bases are the same, they essentially eliminate. There is a process where you take the log of both sides in the same base. Not important. You don't have to actually know that yet. And really what this now becomes a question of is what is 2x plus 2 equal to negative 3? Can I isolate for this? This looks a lot more like a question that I can deal with. So we have this 2. The 2 can go to the other side.
It becomes negative.
That's it. This becomes negative 3 minus 2, which is actually negative 5. And then finally, we divide both sides by our 2. That's it. X is negative 5 over 2. Okay. Now, I carried out a lot of extra steps, which might make it a little more complex. I'm going to do another question where I'm going to not draw as many of the steps in. You can, but I don't want it to be too confusing. So let's do another question here, and I'm going to pull, I like this one here. It's 27 to the power of 4x. This one also deals with another idea. That's why I like it. Yeah, 81, 2x plus 6. Okay, very first thing we need to notice is, I got a variable, and I got a variable on both sides of the equation here. So very first thing I want to do is the same concept as before. I want to get these things to the same base so that I can eliminate bases and just work with the powers. Problem is, off the top of my head, 3 and 81, I don't know what a common base is off the top of my head. So same concept as before, prime factors. Prime factors are an excellent way to break things down. 27. I do know a little bit about 27. I can do 3 times 9. 3 is already a prime number. And then that becomes 3 and 3. Okay. Let's do this one step at a time. That means 3 to the power of 3 is 27. I'm going to put it as a little bracket. And the reason I'm going to do that is because I'm now going to rewrite 27 as 3 to the power of 3. There's still a bracket here, and this power should still stay on the outside. This is going to be important because this is now a power of a power. So we have to use a special law for that one, which is not hard. We've done it before, but the setting up, realizing that this becomes a power of a power is important. The other piece, 81. Well, what does 81 break into? Is it helpful for us? I know I can do 2 9s for 81. And then actually, I can split my 9s into 3s. This is actually really convenient now. I have 3 to the power of 4 is equal to 81. So, same idea. I'm going to make that as a bracket of its own. And I'm going to make this into 3 to the power of 4. And the power on the outside is still there. Now, this is an interesting step. We're almost set with our bases. They're almost the same, except that there's a little exponent in here. Okay? Well, when we bring our exponent in and we simplify, we have to multiply it. So in other words, for our very first one, I have 3, and this becomes 3 times 4x. Go down, out. And our other one, we have 3. I have to multiply this entire thing, so this looks like a distributive property. So this becomes 4 times 2x plus 6. And this is the trickier one. This is a distributive property question. The one on the left, we get 3 times 4x. That's just going to be 3 to the power of 12x. Okay. This one here, I have to multiply by both. Yes. Exactly. 8x plus 24. And now, my bases are technically the same. My bases can drop off, and we're just left with the question of 12x is equal to 8x plus 24. Now, this is a much simpler question. That's it. We bring 8x over. This becomes 4x equals 24. We divide both sides by... That's it. Nice and easy, this one. The trickiest part, though, is setting up of our bases. Okay? So we break them into prime numbers. Can we get the base the same? We plug it in, and then we have a power of a power. So we have to remember that multiplication rule. Once we do that, bases are the same, and we're only dealing with exponents, and that becomes a much simpler question.